So, Stephen D here on Pure 24/7 Radio. And for Pure Media, the magazine, the radio show, I am joined by Sherri Seligson. How are you doing, Sherri?
Doing great. How are you, Stephen?
I'm doing good. Very pleased for you to join me as we
Yes.
talk about your column in the magazine, Pure Media, the magazine. What is it that you do for a living?
I'm a marine biologist and also a science educator. So I currently write curriculum, science curriculum for a creation-based publisher, all about amazing science concepts, middle ages and high school ages in the States as well as internationally.
Excellent. All good stuff. As part of that, you're a contributor to Pure Media the magazine with the column all around sort of science and stuff, since that is your forte. You know what we're talking about. Can you tell us a little bit about the column and what inspired you to write it?
So the column is science and then also faith, and the particular column we're talking about has to do with a squid that lives in a small little remote area off the coast of the Hawaiian Islands. And in studying the creatures that this squid is in a symbiotic relationship with, scientists were interested in bacteria and wanted to learn more about that, about how bacteria can actually do what they do and overcome large animals and humans. And in that, they discovered something amazing about the complexity of these creatures. And to me, that's an amazing thing. The more we study about our world, the more we learn about the world around us, the more amazingly complex and orderly that we find it, which in my opinion points to a designer. And that's exciting.
That is very exciting. I know that this is a great passion of yours. You really enjoy all this kind of stuff. I've read some of your stuff and watched some of the videos that you've put out and stuff like that. Really pleased to be able to talk with you about this. I'm not super sciencey, so I may get some of the terminology wrong and all the rest of it. But in terms of this what do you call it?
Symbiotic,
Symbiotic,
symbiosis. Yes.
the relationship that's happening with this bacteria. Tell us a little bit about that because I'm probably going to get the words wrong.
Oh, it's okay. So when symbiosis is when two or more organisms live together and both benefit, or at least one benefits from the situation of their living together. And in this case, it's a Hawaiian bobtail squid and a tiny bacteria called Vibrio bacteria. Alivibrio is their official genus name. And the in this case, both creatures benefit from their living situation. It's called mutualistic symbiosis. They're mutually benefited by their living situation. And so the bacteria are able to do something amazing. They're able to glow. And scientists were wondering how they do that. For example, if there are very few of those bacteria around, they don't glow. But when they reproduce, can reproduce pretty quickly. Every 20 minutes or so, they double their population. And at a certain point, they all turn on their bioluminescent ability, their ability to create cool light. And so scientists were wondering, how do they know how many of them are around? And they studied them because they live in this relationship with the small squid. They live in two small pouches in the squid's body. And so when they glow, the squid glows. And what the squid does, the squid is nocturnal. That means it's active at night. In the daytime, it sleeps. And then when it comes out at night, it is able to glow because the bacteria are glowing. It also has a shutter that covers the little pouches its bacteria are housed in, and it has a light sensor on its back. So based on the amount of light by the moon, whether it's a cloudy night or a bright night, it adjusts those shutters to match the amount of light. And it literally creates no shadow so that it can hunt kind of in a stealthy way and gather its food. And then triggered by the sunrise, it pumps out 95% of the bacteria. And at that point, there's not a lot of bacteria in those little pouches. And so they don't glow, but that's okay because it's daytime now and the squid's going to bury itself in the sand, sleep through the day. And during that daytime, the bacteria reproduce and reproduce and reproduce and double until there's just enough of them there to turn on their glow at nighttime again. They get a safe place to live. They don't have a long lifespan. So they have a safe place to live in the squid, and the squid gets this beautiful glowing ability to be able to hunt and gather its food. So it's a beautiful mutualistic situation. But how do those bacteria know what they're doing. It turns out that on the outer shell of the bacteria, there are receptors. And these bacteria will send out little hormone molecules, kind of saying, here I am, I'm here. And when there's enough of that molecule around, some of it will eventually get into those receptors and turn on a group behavior, like glowing. And so when there's enough of them there, there's enough of that hormone like chemical around, it makes it into the receptor on the outer shell, if you will, of the bacteria, the body, and it turns on their group behavior. And so they're able to communicate. And that's pretty fascinating. Bacteria are the simplest organisms in creation. And yet they can reproduce, they can hunt, many of them can locomote or move, they can glow, they can do all kinds of things and behave as a group. So think about, I'm sure you've been ill with the flu occasionally, right?
Yeah.
when let's say I'm a mom and I have had young kids in our household, and when the little ones would come up to me and they'd sneeze in my face, I would know, okay, I'm going to get sick just like them, but it's not going to be immediate, is it? You know, in a couple of days, you're going to get it. And that's because some of those bad bacteria get into your body and they send out, all bacteria can do this now. They send out those little I'm here chemicals. And when enough of that chemical is around, then they turn on a group behavior, in this case, virulence, making you sick. And so in a couple of days, you're like, on the couch, I'm sick, because they've done it. So it turns out that all bacteria have this species specific communication ability. They send out their specific language of chemical. And when enough of that's around, they can turn on this group behavior. And that's how come something so microscopic can take down a gigantic organism like me in comparison in just a matter of days. And so not only have scientists discovered that they can speak amongst themselves, they have like a trade language of chemicals that they can understand all other bacteria. And so because bacteria live in environments where lots of different types of bacteria, lots of different species live together, based on how many of their kind are in the area and how many of others are around them, they can decide what they're going to do as a group. And again, these are the simplest organisms in the world. So the conclusion then is there is no simple organism. How did something so complex pop up out of nothing, pop up out of a group of chemicals? And so this little story that I love to share, and I shared in this month's magazine, was about these two creatures and how they live together in a beautiful relationship, which again is very complex, but more about the story of learning about how these simple, quote, simple creatures, and how they're not so simple. They're super complex. Even the simple proteins that make them up, each protein is extremely complex. And so the more we're studying, the more we're learning about molecular biology, micromolecular biology, we are seeing that there's no simple organism in the world. And it's very difficult to explain via small incremental steps how they came to be. They seem to be designed.
Wow. So essentially, the simplest living organism in the world isn't so simple.
That's correct. That's right. They're vastly complex. Everything that they do, communication is just one more addition to the things that we know that these creatures can do. And they're basically a single cell. And back in, let's say, the 50s, 40s, 50s, 1950s, 1940s, they were thought of as just being blobs, just a blob of goo. But they're not. They're complex cities inside this single cell that makes this organism able to do all the things that it does.
That's amazing. So, what would you want people to sort of take away from all of this? What do you want people to be taking away with this?
So I feel like it's important for us to study our world because there's a lot we still don't know. I mean, that's been a historic thing we've seen throughout history in the sciences, that some people feel like, well, everything that's been discovered has been discovered. There's nothing new to discover, but that's not true. We continue to discover more and more things in our world. And so from a science standpoint, that gets me excited. It's an adventure. It's exciting to see what else we don't know and learn more about the world around us. And then the more that we see, the more that we learn that it's complex, it's organized, it's designed. And to me, that points to a designer. Again, it is a truly amazing thing to see how all of these things are intertwined, all of the things in creation, both the physical sciences, the chemical sciences, the biological sciences, all geological sciences. Everywhere we look, we're seeing complexity, order, and design. And so design seems to be the theme here. A designer then seems to be the conclusion that we would come up with when we look at what's out there.
Excellent. Thank you so much, Sherry. That's really fascinating stuff. Really enjoyed reading this article and really enjoyed you expanding it further in this interview. Thank you so much for joining me, Sherry.
Yeah, it was a pleasure to be here.